Hey everyone, this is the IPv6 what is it, multi-lab, dual stacking, routing, a bunch of everything lab, okay, that we did in the HOA the other day. We're just going to do it as a video, all right, so you can better see it. All right, if you didn't participate, hey, you have a better quality of what we actually did. So what we're going to do is let me explain to you what this lab is really all about, all right. As you can see, or let me see if I can move this. There we go. So I can stand to one side and you can actually see the lab. All right, so we have two routers. They're 2811 routers, okay? We have 3 switches under each router. They are 2960 switches. And then we have a computer underneath each switch. All right, each PC, it's its own VLAN. So that means they have their own subnet, okay? Now, you can see there's 2 types of addresses up here, and there's going to be the same if we move this further down. Okay, you see that there's an IP version 4 address and there's an IP version 6 address. Okay, I already worked out the IP version 6 address right here. Okay, I already worked that out. If this lets me, okay, if this lets me move it, come on, move. There you go. If it lets me move it, this is the IPv6 address that we're actually going to go ahead and do. All right, I'll leave this up here for a little bit so you guys can copy that down. All right, but I'm going to show you how we came from this starting point to get to these different networks down here. I'm actually going to break it down for you. And before I actually start doing all this and getting deeper into the explanation of the lab, let me just make a quick announcement to you. In February, I pray and hope that it's towards the beginning of February, all right, at least the first half of February, my IP book will be coming out. Yes, finally, all right? It's going to be on IP version 4 and IP version 6 to include subnetting, all right? All that will be explained. Its purpose is to help everyone, right? The kryptonite, that's why I'm wearing my superhero t-shirt, the kryptonite of all IT or every individual that gets into this field is IP, whether IP addressing, classes, is there classes, class full, all these different things, summarization, identifying a valid IPv6 address, what is auto configuration, EI64, all these different things will be there in a very easy to read, straight to the point. You know me. I'm not going to give you a whole bunch of hoopla because I know that you hate and I hate too reading a book and then at the end of the paragraph it tells you, yeah, well, this will not be part of this book. It's just something that I just wanted to fill in for you, okay? So it's not going to be like that. It's going to be straight to the point, what you need to know. Bang, bang, that's it, okay? I'll give you a very good understanding of IP addressing for version 4 and version 6 as well. It's going to be coming out in February again, and it's going to be through Amazon. It's going to be through Amazon, all right? Anyway, but again, I probably was standing in front of this. You guys couldn't copy it down. But this is what we're going to do. So you need to make sure you stop the video, pause it right here, right? And then write all this down, okay? Because this is what we're going to be working with. I'm going to show you how to get to this, okay? I'm going to show you how to get to this. But we also have an IPv4. So we have a dual stack situation. And that's the reality of all this, okay? The reality is that you're not going to come in. 90% of the time, you're going to walk into a network that's actually already done. They're using IPv4. What are you going to do? Take out all the IPv4 and all of a sudden put IPv6 just like that? No, you can't do that. So you can run IPv4 with IPv6 together, and that's called dual stacking. And that's what we're going to do. That's what we're going to do, all right? We're first, though, going to configure everything with IPv4, and then we're going to go ahead, with the routers, okay? All right. You know what? Let me go to the because it's getting me a little bit upset here. All right, come down here. We're then, after we set the IPs, the IPv version 4, which they're already set. If you look at it, it's already there. I'm sure I don't need to show you how to put in an IP address. Now with the new packet tracer, which I've sent out to the entire world, okay? If you haven't, send me an email, I'll send it to you. You can have a space right here where you can go ahead and put your IPv6. But for right now, we're concerned with the IPv4 part of it. That's it. You know from now, from my other videos, or if you don't know, even in my classrooms, I actually do the first available IP address I put it on the PC. And the last available IP address, I put it on that router. Okay? That's how I do it. And you can see you're using a default mask for a Class C address, right? Default mask for a Class C address. Don't freak out there. There is classes for IPv4. All right? So the IPs are already there. Okay? You need to create it. If you want me to send you this lab, I'll do it. Okay? It's not a big deal, but I think you guys can recreate it. All right? Don't just, it's too easy just for me to send it to you. It's fully complete. And then all of a sudden, oh, well, okay, this is what this means. No, you create it from scratch. You put on your own cables and all the other stuff. All right, after which, we're going to go inside each switch. All we're going to do is create and give it a name, right? Very generic name, switch 1, switch 2. And then we're going to create a VLAN. And then we're going to assign the VLAN. That's basically it. Here, we don't need to be concerned with, we're not going to do any, switch port security. We're not going to worry about STP, right? Or rapid span tree, because there's no redundancy, right? If I were to put a cable between the two switches, then that's a different story. Then we would need to say, hey, which ports are blocked, which ports aren't blocked, which is going to be my core switch. Then that's a different story. Things will change. Okay, but we don't have that, so we don't have to really worry about STP. You can get rid of it if you want down here, but again, this lab is not for that. This lab is just a VLAN lab, how to create a VLAN, assign a VLAN, all right? And then, obviously, the ports that go to the switch, this being your core switch, you need to be trunked, right? Switch port mode trunk. You need to trunk those ports. And that turns on the 8021Q, right? That's the one that we want to use. That's the type of encapsulation. Also between port 24 here and the 0 port of the router, that also, port 24 on the switch, that also needs to be trunked. Why is that? Because we know that only VLAN 1 can go across access ports or trunk ports. Other VLANs that are not VLAN 1 must go across trunk ports. Okay, so VLAN 2, 3, 4, all the way, I think the number is up to 1001. They have to go through a trunk port. In your certification, even the new one, all right, you're not going to have to configure that, but they're going to give you print screens. All right, it's going to have two switches connected together, various VLANs on either side, and they say that the admin, hint, hint, the admin VLAN can talk to each other, but the other two VLANs can't. And that's why, because in the output that they show you, the ports between each switch are set to access mode. So ports between switch to switch, if you're having other VLANs, then the native VLAN, the admin VLAN, whatever VLAN, the native VLAN, they must be trunked. Okay, they must be trunked. So we'll be doing those trunk ports. Then finally we get to the router. I keep doing that. Let me bring this down a little bit. Okay, then we'll go inside the router. And in the router, what we're going to do is, we need to, remember, there's a router on a stick, right? We want to have one connection to the fast Ethernet, but we have multiple subnets. So we need to create sub-interfaces. Once we create the sub-interfaces, now, the sub-interface doesn't have to have the same number as your VLAN. Nope, it's not required at all. It is recommended, though, just for simplicity. If you say, hey, VLAN 10, sub-interface 10, oh, that must be for VLAN 10. So it's just for it to make sense. But the encapsulation, all right, for that particular sub-interface must match that VLAN number you created, because that's called a VLAN ID. Because when you do encap.1Q, the number that's following it is the VLAN ID number, which is, in our case, VLAN 10 or 20, 30, or 40, whichever VLAN it is. That is required and must match the VLAN of the actual LAN, okay? So then after we do that, we'll put in the IP address, which is the last available for that subnet. And then we do the same thing for VLAN 20, okay? We will then go ahead and configure, of course, our IP addresses. Now notice, I use serial cables just for you to practice, to remind you that if you have a DCE, a data communication side of a router, okay, you need to put some clocking on there, all right? So just to remind you about the clock rate command, that is also into the clock rate command here with the IP address, turn it on, obviously. And we do the exact same thing on the other side, just with different VLANs, different IPs, all IP version 4. Great. We test now. We verify that we can ping our own gateways, that we can ping within, within our own broadcast domains in here, right? These two broadcast domains that we can ping from PC0 to PC1, all right? And then we can ping from PC2 to PC3, and we can ping from this router to this router, because we're not routing yet, right? We're going to configure RIP version 2, and then we'll see if we can get across. Once we get across, that's fine, that's dandy, that's not a problem. The thing is now, we need to implement IPv6. So now is when it comes time, and I'm telling you this right now, these addresses, I'm going to put them back up. I'm going to put them way over here. I'm going to make sure I get out the way so you can see them, all right? The notepad, sticky notes, Word, Excel, whatever you like to use, that's going to be your friend. You don't want to type out these addresses. We're going to be putting in static addresses. We're not going to be using the EUI-64, which auto-configurates, right? Gives us the auto-configuration of the interface ID using the MAC address of the router's interface using that triple FE, all right? That's what it does. We're not going to do that. We're going to put everything statically. This side of the address is your network prefix, okay? So the next thing that we'll do is, once, of course, I'll show you how to come up with this, we'll go ahead and put the IPv6 versions of the addresses in, all right, each interface. And I think there's a confusion out there. Even, I believe in certain books, it tells you, you must type IPv6 unicast routing or you will not be able to put an IP address. No, that's not true. You can, if you go inside the subinterface, the same subinterface or the interface that you put an IPv4 IP address in, all you gotta do is put IPv6 address and the IPv6 address, okay? Which would be this plus a number right after the double colons, okay? And that's it, you hit enter, done. You've put an IPv6 address. The only time that you need to put IPv6 unicast routing is when you're gonna route, okay? Which we will. We're doing RIP version 2 for IPv4, but we're gonna go ahead and do EIGRP for RIP, IPv6. And you're gonna see the difference there that you're not gonna be advertising networks like we used to. It's going to be then, once you do your global configuration portion of it, you then enable it on the interfaces that you want to participate in EIGRP. That's all. Not a big deal. I think it's even a little bit easier. You don't have to be worried about, man, did I advertise that network? Did I advertise that network? You actually go into the interfaces. Because think about this. In the old CCNA exam, one of the questions in there was you had to be careful in the EIGRP configuration because they had a passive interface command. This is the hands-on portion of it now. All right, the old CCNA, the 64802, where the EIGRP had a passive interface, and I think it was, I don't know, it could have been facing out to the internet or it could have been facing internal. If you didn't want an interface to participate within EIGRP or not to send out updates, let me rectify that. Not to send out updates, okay? Its interface, you will go within the EIGRP configuration and you say passive interface. You say passive interface, and then the interface where there's S0/1 or F00, whatever it is, okay? And you will put it in there. And then that interface will not send updates. So we don't have that issue now. Because if you don't want an interface to participate in EIGRP, well, then don't go inside that interface and enable EIGRP to begin with. All right, so I think it's a little bit easier now. It's not that difficult. And of course, after we configure all this, and remember, since we're going to be routing, we have to turn on IPv6 unicast routing. And I'll show you. I won't do it. I'll try to do the protocol, and then I'll go ahead and do it, and then you'll see, how it's going to work. All right. So I hope you're ready. I hope you copied all this stuff down. Okay, if not, you have plenty of time. Pause the video, do it, pause the video, do it, and what have you. Okay, so I'm going to go ahead. I'm going to minimize this. Sure I am. All right, I'm going to minimize this. That did it by itself. I don't know how I did. Okay, so the first thing I'm going to do is I'm going to get rid of all my configurations. That's the first thing I'm going to do. I'm going to move the lab over here because I'm going to be standing over here. So I really am going to move it this way. I'll put it right there at the edge, and I'll be standing over here. okay, so you guys can see behind me, okay? And really all I'm going to do, this is nothing, I'm just deleting the information, all right? I'm going to go to each and every switch, and there's two things you got to do. There's two things you got to do in the switch to get rid of all the information, okay? There's two commands. Excuse me. The first command is delete, not the first command, but one of the commands. Delete VLAN.dat. That's the VLAN database. It's going to ask you to confirm. It is case sensitive. So if you like to work to uppercase, sometimes I like working on uppercase. Why? I'm half blind. I can't see sometimes. All right. So everything is in uppercase. That is a file name. You have to put the file name in lowercase. Okay. Keep that in mind. You confirm. And then you erase start. Spell it correctly. I almost misspelled it there. And then just reload. And that, again, should get rid of everything. Now, with the packet tracer, sometimes it gets a little funky. You got to do it more than once. But usually it works just fine. Okay? And I'm just going to minimize this. Okay? Just minimizing it. I'm going to go to the core switch. I'm going to do the exact same thing. All right. I'm going to go ahead and enable, erase, delete, VLAN.dat, enter, 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 and then erase start. All right, and then reload. All right, I'm going to minimize it. Go ahead and open the last switch on that side. And I'm going to make it bigger through here because it doesn't like my fingers. All right. Enable, delete, VLAN.dat, enter, 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 erase, start, Maserat, enter, enter, and reload. So that got rid of the configurations of the VLAN database, and it got rid of the startup configuration, like the host names, and if I were to put clock rates and stuff like that. So two things you want to do on your switches to get rid of it completely, okay? Make sure you get rid of your VLAN database, all right? I mean, this is in your labs. Obviously, don't go to work now and delete VLAN.dat at work and erase start and all that. This is just labs, okay? Keep this to your labs. Little disclaimer there, right? Don't do this at your job. Do this at home, okay? All right, router's much easier. Just do it in erase start, reload. You're good to go. Oops. If you follow, remember, I fat finger the keyboard, which I usually do 9 out of 10 times. Control-Shift-6. Control-Shift-6. That'll break you out of anything. All right. Enable. Erase start. And reload. All right. So let's go to this router, the other router. All right. I'm on this router now. I'm going to do the exact same. Are you for real? I'm going to do the same exact thing. I'm going to erase the start on this router and delete everything on the switches. Okay? We're going to go ahead and get rid of the, we're not going to get rid of the IPs. We're going to leave the IPs as it is. I'll show it to you so you know what they are, but we're going to leave them as is. I'm not going to get rid of them and just to put them back in. I'm sure you know how to put an IP address in on a PC. All right? If you excuse me just a moment. For some reason, I'm sweating. I think it's been a while since I don't film, so the camera lights are killing me. As you can see, I've slimmed down somewhat due to an injury, a major injury that I had, shoulder and bicep. But I'm coming back slowly but surely. Okay, but that'll be another video. All right. So let's go ahead and erase this information. All right, we're going to erase start because we're on the router. Enable, erase start, reload. Now I'm going to go to the bottom switch over here on the left. Let me move it that way. Enable, delete, VLAN.dat. Look what I just did. VLAN.dat, dat, enter, enter, enter. Erase start. Okay, and reload. All right, so went ahead and did that one. Now let's go ahead and do the rest. And you know, repetition breeds retention. The more you do something, the more it becomes second nature to you. That's the kind of labs I like to do. That, you know, it's like, labs, why are we doing the same thing over and over and over again? So it becomes second nature. So now you know. Now when you go take a test, you're like, oh, okay. When you go to your work, it becomes easy. But when you don't do something, you forget. Delete, VLAN.dat, enter, enter, enter. Erase start, enter, enter. Reload. Okay, and then the last switch. Same thing. Put that over here so you can see what I'm doing. Enable, and I'm typing shortcuts EN. All right. Delete, VLAN.dat, erase, start, reload. All right. So we've gotten rid of all the configurations of our internetworking devices. Now it comes time to start configuring the lab. So the first thing that we're going to do is, and I'll leave it right here, we're going to start with that switch over here. Then we'll come over to this switch, then we'll do it. We're going to name the switch, create the VLAN, name the VLAN, and then assign the VLAN to a range of ports. And then do the same, and of course, trunk the port that is necessary, which is F022. And then we're going to do the same thing over here. Remember, this is VLAN 10, this is VLAN 20. Let me show you the IP addressing of it. Okay, VLAN 10 is going to be 192.168.10.1 will be the IP address. We're going to use a 24-bit mask, and the gateway is 254. That is the last available IP address on the network. Okay, and the same thing will be for the 20. It will be 20.1, 20.254. Okay, so that's the IP scheme for the IP version 4. We'll go back again and we'll look at the version 6, but I just got a 1 and an F. It's hex numbers, but we'll get there. I'll explain. All right, so we really don't need to touch none of the PCs. Just know that this is VLAN 10 and this is VLAN 20. So let's go ahead and start. Okay, we're right over here. All right, we're going to name it something very generic. Config T, host name SW1. All right, and now we're going to go ahead and go right into the VLAN. VLAN 10. There, we created a VLAN. Now let's name it. Name, faculty. Now we need to assign it. Now, in order to assign it, we need to go into a range of ports, right? So we're going to go or to port by port, however you want to do it. But since we're going to do a range of ports, it's int range F0/1-10. Now, by default, the ports are set to dynamic auto. You cannot assign VLANs. You cannot set switch port security on ports that are dynamic auto. You got to change the port type to an access, or the mode of the port to access. Okay? So the first thing I'm going to do is do the command to make these ports access ports, and then I'll do the command to actually assign the VLAN. So switch port TCH mode access, and then switch port TCH access VLAN 10. That's it, right? Created it, named it, assigned it to a range of ports. Now I'm going to trunk that one port, which is facing to the core switch, which is port 22. Interface F0/22. Switch TCH port mode trunk. Okay, now that port's trunked. Now in your exam, remember this is a foundation exam. They want to know that you have to that you know your copy run start command. So they make you go back to privilege mode. Yes, you have to go back to privilege mode and type copy run start. They want to know that you understand that. There is a shortcut which is called WR, all right? And also with the newer iOS like 12.4, all right, you have that do command where it doesn't matter where you're at in the router, as long as you type do and then the command, you can do it right from there. You don't have to go back to privilege mode. And that's what I'm going to do, a little shortcut, okay? So I'm going to do WR. What would you do in the certification exam? You would type exit till you get to privilege mode. All right, exit, exit, however many times it takes to get to privilege mode, because I don't think you can do Control Z, all right? That would be a shortcut, right? And then you would type copy, run, start. Again, that's in the certification exam. When you're doing your labs, if you're at work, you can go ahead and do the do WR. Again, depending on the iOS that you have, that allows you to do that do command, okay? All right, so let's verify. Do show VLAN. All right, I need to scroll up a little bit. And you can see here's our VLAN 10. There's the name of the VLAN, and it's active. You can see ports 1 and there's port 10. So my job is done as far as that's concerned. Let's take a look at the trunk ports. I'll do a Control C. All right, and I'll do a do show int trunk. All right, and you can see that the encapsulation 802.1q and the trunking is on. So I am done with this switch for the moment. Well, I'm really done with the switch, period. Okay, so we can go ahead and minimize that. Now we're going to go ahead and do this one right here. So open up that one. Let's move it over here. Okay, let's hit enter. Enable config T. Name. Host name, SW2, and now we go to VLAN, VLAN 20, name student. Okay, different VLAN. Well, we got faculty on one side, whoops, faculty on one side, student on the other. All right, now we go ahead and we have to assign the VLAN to a certain range of ports. Int F0/1. Oops, what did I forget? The range command. Range F0/1-10. Right? Now I'm in the range. So again, we need to change them to access ports. Switch TCH port mode access. And switch TCH port access. What type of access? VLAN 20. One too many C's. I just did an up arrow and then I arrowed to the left. Okay. Now I'm going to trunk the port that's going to the core switch, which is port 22, right? So this VLAN is allowed through that port. It can go through that port. So int F0/22 switch TCH port mode trunk. All right, we're going to do a do WR, which is a shortcut, which you can do in your cert. Do show VLAN. Let's verify. Scroll up a little bit. Okay. There's VLAN 20. The name is active on ports 1 through 10. Awesome. Let's take a look at Control C. Take a look at the trunk. Do show int trunk. Which interface is trunked? And did I not do it? Oh, it's 23. Whoops. It's port 23. Forgive me. I trunked the wrong port. Switch port mode trunk. There we go. Do WR. All right. I said it right. I did it wrong. Let's verify again. Do show in trunk. And there's port 23 that is trunked. Okay. So we're done with the switches. Now, you keep hearing me say, when I type switch, I say TCH, because if I don't do that, I always put the H before the C. It's something that I have to do in order to spell it correctly. So it's just something crazy in my head. So we're done with these two switches. Now we got to go to that switch right there, the core switch. And all we do in the core switch, all we do there, excuse me, I'm trying to use the right arm, but it hurts, okay? What we got to do in the core switch is name it. Once we name it, okay, then we're going to trunk ports 22, 23, and 24. And that'll be it. That's all we have to do in that switch. Again, we're not getting crazy with the lab. We're not doing a whole bunch of things. That's all we're doing, okay? It's trunking those 3 ports. So let's go ahead and do that. Enable, config T, host name, core 1, all right, int range, F0/22-24, so 22, 23, and 24. Switch TCH, you see? I didn't say TCH, so I put it wrong. TCH port mode trunk. Enter. All right. Do WR. Do show in trunk. And you can see now that, let me go up a little bit. Too much. That 22 and 23 are the ones that show up. And the only reason 24 is not showing up here is because the router's interface is off. Once that router interface comes on, this will be part of that. Okay, this will be part of that. All right, so we're done with our switches. Now it's time to go ahead and go into this router right here, and we're going to configure the fast Ethernet 00. We're obviously going to first give it a name. All right, let's bring it this way. Let's make it a little bit bigger if we can. No, I'll make sure I'm out of the picture here. Enable, conf T, host name R1, okay, interface F0/0, enter. Now, there is no need, there's no need, you cannot put 2 IP addresses for 2 separate subnets on that one interface. That's why this is called a router on a stick, and that's why we have to create subinterfaces. All you do on this interface, the physical interface, is turn it on. That's it. That's all you got to do. Once you turn it on, then we can start creating our subinterfaces, okay? So we're going to go ahead and do no shut. Turns it on. Interface F0/0 dot. I'm going to do 10 first, so therefore 10. Encap, short for encapsulation, dot 1Q. This must match the VLAN ID, in this case 10. And then the IP address. IP address 192.168.10.254. 255.255.255.0. Enter. Now, there's not a battle, but I don't know what word I can use that people don't, because they come from other classes. They say, well, we use in our server, we use this address and we use that address for their. You can use whatever address you feel like it is your particular network. So whatever's going to make you happy, you decide. I personally like using the higher addresses for the switches and routers, the lower addresses for the PCs. I don't care what anybody else says. This is my network. I'm going to put it the way I understand it and the way I explain to my IT staff. This is the way it's done. This is my documentation. This is the way it is. I've created the LAS standard, period, okay? So does it have to be that? No, but under the LAS standard, that's what I like to use, okay? Just so you be aware. Now, since this is a sub-interface, there is no reason to turn it on. You saw that it went up anyway once we created it. Now, in order to speed things up, and you may think I'm going a little fast, but I'm not. Again, remember, you can pause the video. Pause, go back, pause, go back. All right, I'm going to use the up arrow command so I don't have to type as much because, again, my right hand is killing me. I'm going to go up. Now I'm going to take out. I'm going to put 20. That's my next sub-interface. You see how it goes up. All right, now I'm going to put the encapsulation, which needs to be 20. 20. Hit enter. And now I need to put the IP address. Instead of being at 10.254, it's 20.254. All right. Up arrow. Then I do a back arrow. Okay, let me make sure I'm out of the way here. Get rid of that 1, put a 2. I'm going to do a Control Z, WR to write. Okay. You would do exit, exit, copy, run, start. All right. I'm going to do a show IP route, which means I'm looking at my routing table. And you can see that I'm directly connected to 2 different networks under those 2 sub-interfaces. Another verification, show IP int brief. Okay, and let me open this up a little bit more. Okay, one of the things that you want to see, and let me get on this side. Saw that? This is a martial arts move. All right, I got 2 different sub-interfaces, one for each VLAN, and then I have the IP addresses, but most importantly, when you're looking at this command, that says that both the protocol and the lines are up, and they're both up, up. So I should now be able to ping if my trunks are done, okay? And we're going to go back to that core switch. I'm going to take a look to see that port 24 showed up, that it is trunked, okay? So we can ping from PC0 to PC1. All right, let's go ahead and do that. Let me minimize this router, okay? Let me open up, well, let's open up this switch first. How about that? Look at that. All right, let's do a Control Z here. Let's do a WR just in case. I always like to do a copy run start or a WR just to make sure everything is saved. I'm going to do a show IP int trunk. How about show int trunk? Sorry. And there you can see port 24 has shown up. You can see now port 24 is part of those that are on. So that is trunked. Let me go ahead and close it. Now there should be no reason why I shouldn't be able to ping. I hope you can see this because I know the letters are in white and the background is in black. But I think you should be able to see only the what's on the screen there. So we're going to ping 192.168.20.1. Let's just go for it. Instead of pinging the gateway and then pinging the other gateway and then pinging the PC, let's just go straight for the PC. And remember, in Ethernet, one of the things I explain in my book in a very quick and easy way, you will always have, that ARP broadcast that we don't, that now in IPv6, there is no more broadcast, right? So, but in IPv4, we still have that ARP broadcast that exists, okay? So that's why you see the first is always a request timeout, because it's, hey, what's your MAC address, router? Okay, thank you very much. Now I complete my packet. Well, here's where I want to go. The router looks at his routing table and then sends it on its way. And the same thing happens on the other side. In this case, on the same side, because they're connected directly together, all right? So we do have connectivity. We do have connectivity in this particular section of the network. Now we're going to move over, not the PC. Now we're going to move over and we're going to go ahead and do that triangle. Okay, we're going to do the exact same thing, except that this is VLAN 30 and this is VLAN 40. Therefore, my IPs are what? 30.1, right? Let's put this over here. Not that. All right, my IP is 30.1. I have a mask of 24 bits. And then my last available is 254. You can see the IPv6 is already there also. Okay? All right, let's go ahead and close that. Let's close that. All right, so let's go ahead and begin. Same thing we just did, just with a different network. So let's go ahead and open up that switch. Cool, it's already there. Let's bring it up a little bit. This is switch 3. Enable, conf t, host name, SW3, okay. Now let's create the VLAN. VLAN 30, name, faculty 2. Not very, creative, but hey, it works. All right, faculty 2. Now we need to go ahead and assign a range of ports. Int range F0/1-10. Again, consistency. And then we need to change the ports to what? To access. Switch TCH port mode access. Switch port, look, I wrote it correctly. Access VLAN 30. Right? And now we trunk port 22. And I'm going to verify this time because I don't want to mess up again. 22 and the other one is 23. Okay. Int F0/22. Enter. Switch TCH port mode trunk. Do WR. We're done. Let's do a show VLAN. Let's scroll up a little bit. 1, 2, 3, 1. There it is right there. There's my VLAN, the name, and the port that is assigned to. As you can see, it goes from 1 to 10. Okay, we're good there. So do a Control C. Show int trunk. Again, to verify that I indeed trunked it. And I did. So, therefore, I am done with that switch. Now I'm going to go to this switch right here. Bring it up. Okay. Enable conf t host name SW4 VLAN 40 name student 2 or students 2, whatever. Okay, now the range of ports, int range, okay, F0/1-10, and then we change the access, switch, port mode access, and then switch, TCH, port access, I'm sorry. Slow down, lads. Okay, VLAN 40. And then let's trunk port 23 this time. So we go to interface, F0/23, enter, switch TCH, port switch port mode trunk. Enter. Do WR. Do show VLAN. Scroll up a little bit. And there's our VLANs right there. Control C. Do show int trunk. And we see port 23 is trunk. So again, now we're done. It was the same thing we did on the other side. So we're done with the two lower switches. Now we got to go to the core switch and make sure that we give it a name. And then we just trunk the ports around it, which is the same as 22, 23, and 24. Right? Switch to switch, switch to router. We must trunk those ports for all the other VLANs. So let's go ahead and open up that switch right there. Let's move it up. Let me draw myself a little bit here. Somewhat hot. Okay. All right. Enable config T. Host name core 2. All right. And now we're going to trunk them. Int range F0/22-24. And what we're going to do now is do the same command that we've done before. Switch port mode trunk. Switch port mode trunk. Awesome. Do WR, do show in trunk. Okay, and again, it's only going to show 22 and 23 until we turn that port on the router on. Okay, so now, hey, let's go do that router. We're doing the F00 on the router. The F00 on the router. Okay, let's give this router a name. This is host name R2. All right. Interface F0/0. Again, we do nothing on the physical interface because this is a router on a stick situation. We have multiple subnets. So all we need to do is turn it on. Now we do the sub interface for 30 int F0/0.30. That's our first sub interface. The incap dot 1Q30, right? And then the IP address 192.168.30.254.255.255.255.0. Enter. So that takes care for that VLAN. Now we need to do it for VLAN 40. Again, I'm going to up arrow just to make things quicker. Go to the sub interface command. Going to change it to a 40. Hit enter. Enter again. Going to go to the incap. Must be done before you put the IP address. 40. It won't allow you to do it the other way around. And then the IP address, which in this case, all I got to take out is that 3 in 30 and put a 4. And that's 40. Okay? I do a do WR. Let's take a look at do show IP route. Take a look at our routing table. And you can see we're directly connected, right? We got two C's, so we're directly connected to 30 and 40. And if we do the do show IP in brief command, do show IP int brief, we're going to see it says up. You can see it up here. All right. Well, what you want to see is up, right? You want the protocol and the line both to be up. All right. The only time you're going to see like an up down, if some sort of encapsulation, some CRC errors, things of that nature, or if you're doing it on a serial interface because no clock rate was put on there. But there's a fast Ethernet very rarely. If you may see a down, all right, which means a physical layer problem, but very rare that you'll see an up down here. Up. If you do a wrong encapsulation, let's say you have a mismatch in your encap that wants you with an ISL, then that could be an issue there. All right, that's what an up down means. Here we see that it's up. We should be able to ping now, and we'll just go for it, right? We're not going to go step by step, you know. Let's ping our gateway, the next person's gateway, and then the actual PC. We're just going to go for it. And 192.168.40.1. And again, the first one should be always a timeout because it's the first time you're pinging it, and it should give you, that ARP. It's trying to find out that ARP, and then you should get your replies. If you were to ping again, you would get 4 replies because you already have that internal cache. So you don't have to worry about that. All right, so we're good to go. We know we can ping our gateways. We know we can ping within our network, right, or our infrastructure. Now we need to ping between these two routers. So I'm going to do this router first. You can see the IPv4 address is a 10.114 with a CIDR 30. So we're in a VLSM environment. Ooh, VLSM, right? We don't want to waste any IP addresses, so we're using a CIDR 30. Something that when you see this, just to give you a heads up now, this /54, that is not a subnet mask. That is a prefixed length, is used for routing purposes. Has nothing to do with what subnet mask means in IPv4, okay? But here it does. So we have a 10.114, which means we have a 252. We only have 2 IP addresses that are available. This one's going to be the .5. That one right there is going to be the .6, okay? So we're going to do this router first. And, okay, is the S010, okay, S010, and that's the one that has the clock rate. Okay, so we're going to enable config T, interface S0/1/0, IP address 10.1.1.5, 255.255.255.252. Enter. Clock rate. Again, clock rate deals with the physical speed, depends on the type of media you have. Here in the simulator, we can pick the fastest clock rate. So the fastest clock rate is 4 million. Wait a minute. 123, 123. Somebody's paycheck, right? 4 million a second. And then no shots. If you don't put a clock rate, you're going to get that up-down situation, okay? So let's do WR. We're okay with that. Let's minimize that. But here, let me show you. Let me show you something before I do show IP in brief. Okay. And here is your S010. S010. It's telling you down. You say, well, it should be is it not encapsulation? No, it's down because the other interface on the other side of the router was not configured. That's why it's down. Okay. If you didn't know, now you do. Okay, let's minimize. Okay, and let's go ahead and go to this router right here and go to, what interface is that? That's S011. S011. Don't let me forget. S011. Just scream it out, even though I can't hear it. Interface S0/1/1. IP address. One too many S's. 10.1.1.6. 255.255.255.252. Enter. No clock rate needed. This is the DTE, terminating portion of it. All right. No shot. I got to do is turn that bad boy on. And then let's just do WR, or WR in this case. And let's see if we can ping the other router. All right. So we're just going to ping. Get a prompt here. Ping 10.1.1.5. Cool. We got 4 bangs. All right, there is no ARP between serial. ARP only exists in Ethernet networks and IPv4. All right, so I can go ahead and close that. So we do have connectivity between these two routers. We have connectivity here and we have connectivity here. But the goal, obviously, is to have connectivity across the board. All right, now we're in IPv4. I said we were going to configure RIP version 2. Not a problem. Let's go ahead and do that. All right, now remember, RIP version 2, RIP version 1, RIP-NG, all these are distance vector routing protocols. They still have a maximum of 15 hop count. Okay, they do use multicast addresses now. Okay, RIP version 1 use broadcast addresses, where these other two, RIP version 2 and RIP-NG, use multicast addresses. Now, one of the main differences between RIP version 2 and RIP-NG, RIP version 2, we are actually advertising networks. Okay, with RipNG, we actually go into the interface and enable the routing protocol itself. Okay, all right. So let's go ahead and continue. All right, I'm going to go to the first router. This is very quick, very simple. I'm going to type exit 1 so I can be in global configuration. All right, I'm going to do router rip ver2, short for version. Net, I'm attached to 2 networks, right? Or 3 actually. 192.168.10.0. Enter. I'm going to up arrow, get rid of the 10, put a 20. All right, so those are the 2 VLANs, right? And then I'm attached to that 10.114, but really what you put is 10.000 because it doesn't understand that that's a class A address that has been subnetted. That is one of the reasons that you must type no auto hyphen summary. If you do not type that and you're in an IP version 4 world, it's not going to know if you have a class B address or a class, doesn't matter, class A, class B, or class C, that's subnetted, okay? It's going to assume the class full boundary of that address, CIDR 8, CIDR 16, or CIDR 24. So if it is in a subnetted environment, okay, and you don't type that no auto summary, it's going to assume that everybody's in the 10.000 network, okay? So, or the 172.16.000 network, or whatever it is. All right, so be very careful if you're asked a question on IPv4 for a routing protocol that what is the problem on, and they're using a RIP version 2, okay, or an EIGRP, all right, version 2, or version 4, I guess, because now it's version 6, all right, whatever it is. For IPv4, they're both distance vector. They both, you had to type no auto summary, all right? That is key. All right, let me go ahead and get rid of that. Let's minimize that. All right, you know what? I'm not playing this game. All right, let's minimize that. Let's come up here. And let's do the same thing here. Just different networks. Config T, router RIP, version 2, network 192.168.30.0, enter, up arrow, get rid of that 3, put a 4 for the 40 network, right? And then the same network, the 10.000 network, we're attached to that network. We have to say, hey, I'm attached to this network too. Okay, and then no auto hyphen summary. All right, so we'll do WR. Now, I'm going to do a Control Z. Now, if everything is working, when I look at my routing table now, I should see what? I should see Rs. That means RIP. Okay, so show IP route. And now I see Rs. I see my 10 network because I'm on the second router. So I see my 10 network, I see my 20 network. Okay, cool. Let's just ping. Let's go from this last PC here. Okay, let's go to the desktop, command prompt, and let's ping 192.168.10.1. And we got a reply, Control C, 20.1. And we got a reply. And we know we can ping ourselves, but let's ping the routers. Well, it just doesn't make sense. Doesn't make sense. Because if you can ping all the way out there, we already verified that we can ping within our own LAN. Now we just pinged all the way out here. So we have connectivity all the way across. It is simple with IP version 4. It is not a big deal. Now it comes to IPv6. Okay? The first thing that I'm going to do for IPv6 is explain to you, okay, because I use the same method. I use the same exact method for subnetting in IPv4. I use it in IPv6. And believe me, if you want to go and look up the math, you knock yourself out, okay? I can tell you right now, in a real world environment, you're going to be using a calculator. If you use a calculator now, you can believe me, you're going to be using a calculator big time, okay, when it comes to IPv6. Nowhere in the certification they'll ask you to subnet. Okay, I doubt it that they'll ever ask you to subnet because there's a lot of tricks depending on the number that they give you, subtracting and adding and all this other stuff that you got to do. So I'm going to give you just a very easy example on the basics of subnetting, because subnetting IPv6 have many different levels. Okay, so let's go. Let's knock this out. All right. So you have an existing. Now, why would it? Well, okay, you can leave it there. You can see that. Better for me. All right, I'll go this way. You have an existing network that's IP version 4. You say, hey, boss, you know, IPv6 has a lot of great new features, man. You got IPsec built in. There's no more broadcast in there. You know, I mean, just the fact that the way the auto configuration, the header, it's a lot smaller. I mean, the processing speed, the way the router reads the routing tab, everything is going to be a lot better. It's just much more streamlined and more secure than IPv4. Just the fact that, you know, it has no broadcast, that should be, hey man, you got me. You know what I mean? And the fact of the matter is that we've ran out. We've ran out of public IPv4 addresses, and that's what they mean. Okay, public IPv4. With IPv6, the number, it's what, 384 undecillion addresses. Each IPv6 address, you can have 18 quintillion. I think I have a video out there that says that. 18 quintillion addresses. You're never going to run out. You're never going to run out of IP addresses. Okay? All right. So you sold it on your boss. He said, all right, you know what? Laz, go right ahead. Knock your socks off. Create me an IP scheme for my network. Tell me, you know, let me look at it, document it, what have you. All right. So let's say my ISP gives me 200. This, by the way, 2001 is a global prefix. Okay? 3200 would be the ISP. 1600 is what the ISP gives the company. Okay? So now you're left with this last section. That last section, because each section is 4 bits. What you're looking at is hexadecimal numbers. So each bit, each value, each number is 4 bits long. So 4 times 4 is 16. 16, 32, 48, 64. So, and this is only the network prefix side of the address. It's a 64-bit network prefix side and is a 64-bit interface ID side. Okay? So, this section right here, this portion of it right here. Let me see if I can get away with doing this. Probably, no, of course not. Okay, where that 2000 is, next to the double colon, that one right there, that is your subnet section. That is where you're allowed to say, hey, let me move my line to see what subnets I'm going to create. Now, you may be saying, why in the world, Laz? You just said I can have 18 quintillion addresses. Why should I subnet? Of course you got to subnet. You still got to segment your network. You got to break up all that broadcast security at least, right? So you are going to go ahead and subnet. All right? So now this is your starting point. They're giving you a 51. So remember what I said, 16, right? 16 bits here, plus 16, that's 32, plus 16, that's 48. They gave you a prefix length of 51. So 49, and I don't know if you can see that way out there, so let me bring it over here. Okay, so you got 49, 50, 51. That's where that first line is at. All right, that is your actual starting point. 51, you can't go behind that. Okay, you want to count from left to right, like in IPv4, for subnets. Now, how many subnets do we have? We have 1, 2, 3, 4, and the one between the routers is 5. So what we need is 5 addresses, or 5 networks, I should say. 5 networks. Excuse me for a second. All right, 5 networks. Okay, so we need to count from left to right to a number that gives us 5 networks. So we start by 2, correct? Now, I'm still getting a lot of questions. Why do we count by 2? Remember, guys and gals, the formula is 2n minus 2, right, for host. All right, so we take 2 to whatever number of zeros or ones, all right, and that gives us the number of bits on or off when we subtract 2, okay? So I don't do that because I didn't memorize 2 to the 15th, what that means. All right, so that's why I tell you to count 2, 4, 8, 16, 32. Okay, so 2, 4, 8. So that's where my second line is. Okay, my second line is your new prefix length, which is a 54, because we have to move the line 3 bits over, right? So just like in IPv4, the bit value to the left of that line, that's the increment. So well, these are hex numbers. 1, right? If you look up here, 1, 2, 4, 8, right? Those are the values. So that 0 to the left of that line, that bit value to the left of the line is 4. So we increment the network by 4. So we start with our starting point, which is 2000, with the new mask, and we increment by 4. So we got 2000, and then you see 4, 8. Now look what happened here. Well, 4 and 8 is 12. But remember, in hex, 12 is what? C. 10 is A. 11 is B. 12 is C. Remember, we're in hex. So now we add 4 to 12. 4 to 12 is what? 16. What's the maximum value in hex? 15. So just like in IPv4, okay, we reached the maximum value. That resets to 0, and you add a 1 to that one, making it 3. Okay? And then you keep incrementing by 4, and that will make it 3, 4 for that one. That's all there's to that. Now, a little bit of terminology. This 2000 are these bits right here. 4 bits, 4 bits, 4 bits, 4 bits is 16 bits. These are the 16 bits that are here. I call this position 1. That's my terminology. Position 1, which is where the 2 is at. Position 2, position 3, and position 4. That is where you need to pay attention to when you're subnetting IPv6. What position are you incrementing by? Like in IPv4, what octet are you incrementing by? In this case, what position are you incrementing by? And you're incrementing in the second position. Okay? All right, so this is how I came up with these numbers with the new prefix length. Now again, this is the network. On this side, we said we're going to do static. Well, I'm not going to come up with a whole 64-bit, well, I don't know, A, B, C, D, F, G, H, I, 1, 2, 3, 4. I'm not going to do that. So all I'm going to do is, for all the PCs, it'll be 1 down the board, all the way down. That means it's all zeros to the very last number, and then you got a 1. Okay? And for the router, it's F, just like you saw. Now, this is going to be a handy tool for you, because I'm going to be copy-pasting this address big time. Okay? Big time. I am not going to be typing this at all. All right? So let's check it out. Let's check it out. Let's go ahead and let's look at the PC. 0. All right. Let's go to the IP. You can see the IPv6. We got the 2000. All right. And then you got that 1. This, your FE80, that is your link local address that will always be present there for you, whether it's DHCP enabled or not. Okay. If, let's say you wanted to use that to go back and forth between your router, you could. Inside the interface, you can do IPv6 enable. Done. It will use your link local address to network. Okay. And then here's your gateway, which has an F, which is the maximum value. All right. So this is the address that we need to input in that sub interface for VLAN 10. All right. That's the one we need to do. So let's go ahead and copy that. You know what? There's the mouse. How about that? Is it going to be easier for me? All right, because this confuses me here. Okay. All right, we're going to do a Control-C. That's copied. Let's minimize that. That way I can keep my right arm down. All right, so we're going to go Enable. Conf-T. And we're going to go int F0.0. No, /0, sorry. .10. That's that sub interface. So now, how do you put an IPv6 address? All right. Well, IPv6 address, and now we're going to paste. That's the F. All we got to add is the 54. So that's our new prefix length. And hit enter. That's it. We're done. We're putting that IPv6 address. Not a big deal. It's a static address. Let's make sure we copy this. Do WR. You see that I didn't type IPv6 unicast routing. I'm not routing yet. Okay? Let's see if we can ping that address. All right, let me open up this PC again. Let's up arrow. Let's backspace that. Let's paste. Ooh, let's give it a space here. And we get a reply. So we are pinging now through IPv6. Awesome. So let's do the same thing all the way across the board to all the PCs. All right. Now I got to go VLAN 20. Let's move this way. So you guys, okay. So you guys can see. That's the 2400 network. There's the value. Control C. Minimize that. Go in here. We're going to up arrow. Change that from 10 to 20. The new IPv6 address. We're going to paste it, which is the 2400. F, all you got to put in is the CIDR 50. Oh, not CIDR. Prefix length. Prefix length. Enter. You go do WR. Enter, and let's verify that we can ping it. I always like to verify because you never know. With packet tracer, the way it is, you know, it'll be funky. PING. Right click and paste. And we have a reply. Awesome. Let's do the same thing with this guy. Come here. Control C. All right, that's VLAN 30. I'm going to enable conf T, enter, interface F0/0.30 IPv6 address, and I'm going to paste it. It's 28. Just put in the side, the prefix length. It's hard to start getting used to it because you want to say CIDR, but it's not a CIDR. All right, hit enter, do WR. Enter. Let's go ahead and close that. All right, and again, we're going to go ahead and verify. Let me, my God is hot. This is my, I know we're in the, the tropics, but my God, I feel like I'm in some island somewhere. I don't know. Maybe I am. You never know where I'm at. All right, let's go ahead. That was silly. Let me go ahead and ping. And then we'll right click paste. Okay. And we get a reply. Come to the last PC here. Let's close this. Go to IP. Let's go ahead and copy this. Control C. Okay, let's go to the router. Up arrow for VLAN 40. And now, of course, let's move this to the side. I want to make sure you guys see that. VLAN 40. We're going to up arrow again, because now I'm just going to go ahead and get rid of all this. Paste. Okay, enter. I forgot the prefix length. Enter. Do WR. Enter. Okay. Now let's see if we can ping it. PING. All right, beautiful. So now we're pinging with IPv6, at least within our own structure, our own gateways and stuff like that. But now we need to get all the way across. Now is when we do the IPv6 unicast routing, and we're going to use EIGRP as a routing protocol. So let's go ahead and do that. Let me put this mouse down here. I can be a little bit quicker. All right. IPv6. I hit tab. Unicast routing. Enter. Because now we're going to forward packets for IPv6. IPv6. EIGRP. 100. Well, if I put router first, it will work, right? IPv6 router. EIGRP. 100. Okay? Now we got to give it a router ID. The router ID, and now when we're doing these protocols, is just to say, hey, this is a certain instance of this protocol. All right? That's all it is. It's a protocol instance. So you go router ID, I hit tab, 1.1.1.1. It could be whatever version. It has to be a version 4 address, by the way. But it could be whatever version 4 address you want. Okay? And then you must turn on the protocol. So these are the 3 things that are required first, okay? All right, that you got to do. You got to make sure, and again, with the EIGRP, the autonomous systems, all routers have to have the same autonomous system, which is 100, all right? You got your router ID that expresses, hey, this is this instance of this routing protocol, all right? And then turning it on. So now let's go to each interface. Interface F0, which router am I in? Router 1, okay? Interface F0/0.10. Enter. IPv6 EIGRP 100. That's it. 20. 100. And I forget what the serial interface was. S010. Okay. So interface, well, no, that was not good. Interface S0/1/0 EIGRP 100. Do WR, enter. S010. I just want to check again. Okay. So that one's done there. Let's minus that, and then let's do this one. And this is the last step, really. And then we'll just do a couple of verification commands and a little explanation. Exit. IPv6. Again, I hit tab. Unicast routing. Got to turn on. IPv6 router EIGRP 100, the autonomous system. Okay. Oops. The router ID 2.2.2.2. Okay. Now we go into the interfaces. Interface F0/0.30. IPv6 EIGRP 100. 40. EIGRP 100. And again, as usual, I forget. S011. Okay. Interface S0/1/1. EIGRP 100. Do WR. Okay. Did I turn on? I never turned on the router, you see? So I'm going to go back to, I never turned it on. I didn't do a no shut. You see, it says router ID right here, but I never did a no shut. And how did I realize that just now? I realized it because I didn't get an adjacency that had to be created. So I'm going to go IPv6 router EIGRP 100. No shut. Okay, and then we'll do WR. And I should be getting adjacencies. It may take a little bit. Let's take a look at the start. Show start. All right, there's our IPv6 unicast routing. There are 2 IP addresses right there. one for version 4, one for version 6, and we have IPv6 EIGRP enabled on that one. Same thing here. Okay. We have S011 and there's 10.1.1.6, boom. We never put an IPv6 address on S, and you can see where this troubleshooting comes in. So I need to go back. I never put IPv6 addresses on the routers, did I? Okay, so let's go ahead and do that. Well, this is the network right here, 3000. So this will be 1 and this will be 2. All right. So I am on router 2. So this is the 3000 network. Control C. Or really I can just, yeah, Control C. All right. That's hilarious. Config T. Interface S0/1/1. Enter. IPv6 address. Paste. :2/54. Enter. Do WR. Okay. Let me go to this one now. Didn't I say I forgot to do a no shot? Oh, I already did it. Okay. All right. And let me go into this interface, which is, let's verify that this is the correct interface. S010, yes. And let's put an IPv6 address. IPv6 address. Paste. This is still in memory. This will be :2/54. Enter. Do WR. So that should be it. I should be seeing some sort of an adjacency soon. Show IP route. Show IPv6 route. Okay, I'm still not seeing an adjacency with that one. Let me take a little bit. Let's go through the start and make sure that everything was done. Unicast routing wouldn't allow me to configure it. There's the IPv6 address. For fast Ethernet, IGRP 100. There it's 100 again. There's a serial with 100 and an IPv6 address, clock rate, all that good stuff. Here's RIP. Here's EIGRP and no shutdown on that one. Okay. Let's go back to this router over here. Control Z. Control Z. Start from the get-go. Show start. Unicast routing. Start 30. EIGRP 100 with IPv6. IPv6 address. Same thing. Okay. There's the routing protocol. And there's the no shutdown command. But I am not getting show IPv6 int brief. Everything looks up. On. You can see your link local address that's there, 2001 FF. There's the 2. And it's up as well. Okay, for the S011. Okay. So it should take it. It should take it. Don't know why. I did it in the HOA. I don't know why it's not doing it now. Like I said, it could be a finicky. It's a finicky protocol. I might have missed something. If you guys catch something, please let me know. Something that I missed at IPv6. I don't think I missed anything. Everything is on there. All right, let's go ahead and reload the router. As usual. Okay, I did a WR. Okay, tell me what my mistake is, gentlemen. Look at my lab and tell me what my mistake is. August, I shut it down. That's right. I thought I never turned it on. Wow, silly me. WR, reload. All right, let's see what happens. Let's open up this, let's maximize this router where it opens. Dual exchange, okay, neighbor exchange to the link local address. One up, one new adjacency, so it took time. Let's see. It looks like everything may be working now. It took a while. There you go. Let's see. Enable, show IP, V6. Route, there we go. That's what we wanted to see. There are our Ds, okay? So again, packet tracer is kind of hot in here. Maybe the computer is taking a beating. I know I'm taking a beating. But this is it. The book that's coming out in February, okay, explains all this, and the step-by-step configuration is there. All right, so no worries. If you have questions, you can always call me. All right, take a look at the lab, practice the lab. Okay, the more you practice, the better you come at it. But very easy. Your IP scheme comes first. Okay, IP scheme first. Then go ahead and do your switches. Then do your routing. Work on one infrastructure first, one side, then the other side. Make sure you have connectivity within each side. Then go ahead and try to get across. Okay? But that's a dual stacking. You have two routing tables, two different types of IPs. All right? So when you're troubleshooting, you either do, because you saw that the IPv4 was good to go. So you got to do show IPv6 in brief. Show IPv6 route. Okay? So that's the way that you will need to do it. Well, I hope you enjoyed it. I hope it looks better now. And if anything, just email me. I'll be seeing you soon, guys. Take care.